In this lesson, we're looking at integration resulting in inverse trigonometric functions. So the syllabus stop point that we're focused on is this one here. Integrate expressions in the form plus or minus 1 over square root of a squared take x squared and a over a squared plus x squared. Now, if you remember from our last lesson, then we went and proved that the derivative of arc sine x on is equal to 1 over square root of a squared take x squared, that the derivative of arc cos x on a is equal to negative 1 over square root of a squared take x squared, and that the derivative of arc tan x on a is equal to a over a squared plus x squared. Now, if we look to reverse each of these, then it makes sense that the following integrals are also true. The integral of 1 over square root of a squared take x squared must be arc sine plus c. The integral of negative 1 over square root of a squared take x squared must be arc cos plus c. And the integral of a over a squared plus x squared must be arc tan x on a plus c. So that's important to understand. We went through the process of finding the derivatives so that we can now apply the integrals. So essentially, this is what we need to know. They're also part of the formula sheet, those three integrals. And now we can look at a couple of examples. So the whole process with each of these examples will be to put it into a form that we can recognize, determine the values, in this case what a is in each scenario, and then perform the integration with the outcome being an inverse trig function. So for this first one, we're looking at the integral of 1 over square root of 9 take x squared with respect to x. Now that will be equivalent to 1 over square root of 3 squared take x squared dot dx. As soon as we put it in that form, we should recognize that it's in the form integral of 1 over square root of a squared take x squared with respect to x, which is equal to arc sine x on a plus c. This is where a is equal to 3. So therefore, it's simply equal to arc sine x on 3 plus c. So it's as simple as that. It's just recognizing that relationship. When we look at the second one, it's a little bit more complex. It's realizing that this here is not just an x. So we're going to use a process of substitution. We're going to simplify this. We're going to look at the integral of 1 over square root of 3 squared take 2x squared dot dx. So therefore we can let u equal 2x, du dx is equal to 2, and therefore dx is equal to 1 on 2 du. When we substitute this all in, 1 over square root of 9 take 4x squared with respect to x is equal to the integral of 1 over square root of 3 squared take u squared. And instead of dx, we've got 1/2 du. So it's equal to 1/2 integral of 1 on square root of 3 squared take u squared dot du, which is 1/2 arc sine of u on 3 plus c. And as u is equal to 2x, we've got 1/2 arc sine 2x on 3 plus c. So we have it. There's our second integral using the substitution method. When we look at part C, and we've got the integral of 1 over 9 plus 4x squared dot dx, we can say this is equal to 1 over 3 squared plus 2x squared with respect to x. And so once we've done that, we can say let u equal 2x, and we can go through a whole substitution process again. Du dx is equal to 2, and therefore dx is equal to 1/2 du. And we can put this back in to say that it is the integral of 1 over 3 squared plus u squared dot 1/2 du. And now we've got 1/2, 1 on 3 squared plus u squared dot du. Now we have a slight problem. This one best fits the arctan scenario. However, the arctan scenario says that it must be a over a squared plus x squared. So as we've determined that a must be 3, we'll need to multiply and then divide by that 3 in order to put it in that form. So this becomes 1 on 6, because we're dividing by 3. Multiply by 3, we get 3 over 3 squared plus u squared du, and now we're in the right form. Now we can say it's 1/6 arctan of u on 3 plus c, where u is actually equal to 2x, so we've got 1/6 arctan 2x on 3 plus c. Okay, so there's 3 simple examples. We'll look at a couple of examples using definite integrals as well. Okay, so in these 2 examples, we have the integral between 1 and 0 of 1 over square root of 4 take x squared dx. So this one's a nice easy one. We can see straight away that a is equal to 2, and we can see it's going to be a sine scenario, so we can see that this is arc sine of x on 2 between 1 and 0. So when we put that in, we've got arc sine of 1/2 subtract arc sine of 0. Arc sine of 1/2 is pi on 6. Arc sine of 0 is 0. So you end up with pi on 6 units squared. When we look at b, we've got the integral between 2 and 0 of 1 on 4 plus x squared dx. We can say that's 2 and 0, 1 on 2 squared plus x squared dx. Now we need this 1 here to be a 2, so we're saying this is 1/2 integral of 2 and 0 of 2 on 2 squared plus x squared dot dx. And therefore we can say this is 1/2, and the integral here is arctan x on 2 between 2 and 0. So we have arctan -1 of 2 on 2 subtract 1/2 arctan of 0. So 1/2 arctan of 1 is pi on 4, and 1/2 arctan of 0 will be 0. So we end up with pi on 8 units squared as a solution. Okay, so essentially that's what we need to be able to do. We need to pick out the patterns. If it is a substitution problem, we need to be able to apply that. There is another approach that you may wish to employ, but I'm not going to go over that in this lesson. Okay, so hopefully this makes sense and you're able to apply this integration process into your already considerable integration skill set.